Hello everyone, I'm Alejandro Garcia. I'm a software engineer at Whitestack, and we have been contributing in OSM, particularly since I think August from last year. What we are going to talk about now is something that Gerardo was mentioning like 20 minutes ago about the adoption of the Hcnv NFV SOL006 standard. I think that some of you, well, it may not be the first Hackfest for you, and for those people, maybe not only some things are new and some are not, but there may be surely some of you that are new, and that all of this seems like a lot, completely new for you. So we wanted to show you and explain you more about this process of this standard adoption. There were actually some questions a few minutes ago about the relevance or the significance of this standard adoption, and this is the slide to tackle that. So, you have already been talking about something of this, as Gerardo was already telling you. Network functions in OSM are modeled in packages, and in particular for the SOL006 standard, we are focusing here on the BNF and network service package, so the BNFD and NSD packages. These packages, as Gerardo mentioned, have some templates, which are the descriptor files. These descriptors specify how are our BNFs on our NS, and as Gerardo mentioned, they can be written either in YAML or JSON formats. We more use this for YAML, and the point here is that SOL006 is the standard which specifies how are these YAML going to be written. So we're going to see that this standard specifies which fields can this BNFD or NSD descriptor files have, and basically they tell you how to structure these files to do what you want. So since latest release, OSM is now aligned with this standard NFV SOL006. Okay, so we are now going to take a little in depth in the purpose of this, and why we align with the standard, what is the purpose, what are the benefits, and we are going to look a little into these descriptors, a little, and at the end we will have a little demo, because I'm going to show you how to convert from older descriptors from OSM 8 to OSM 9 descriptors. So let's begin. First, yes, let's talk about a little about what are these Hcnv standards and how they relate to OSM. Because, many of you, as I was saying, may not have actually heard of this SOL006 standard. So you may be wondering, how is this relating to OSM? Well, all this NFV standardization process emerged mainly from the ETSI, which in English I suppose it is ETSI. which created these ETSI NFV standards. These standards are continually getting reviewed and updated, because what we want here is to incorporate the latest technologies, and we always want to ensure that correct multi-vendor environments are correctly implemented. And at this, the OSM project here on the right is actually a key part, because we can contribute a lot of practical experience about this. For example, well, this Hackfest event we are holding right now is a real example of how we can use these NFV solutions. So, I mean, we as an OSM community can use our experience to contribute back to the standards. So, as a consequence, what actually happens here is that OSM complements the standards of the NFV, and since we are adopting them, this is happening in two ways. So here, our practical feedback helps in this continuous loop in the standardization process, which means we are adopting and helping to improve the standards. Now, looking into this continuous improvement process with a little more detail, this is what was actually planned and executed throughout the alignment to SOL6. So, as we said, we have on the left the ETSI NFV standards, which, as we said, standardize the network function virtualization world. And on the right, we have OSM, the project, the code, which is progressively adopting these standards. Now, for the particular case of the SOL6 standard, which was this one that we adopted on latest release, the standard is expressed as you saw in the last session in YAM models. So for those who have never heard of YAM, and I included myself because I had no idea what YAM was before entering the OSM world, YAM is a data modeling language that allows you to define entities, the structure of those entities, and how they relate between each other. So what this YAM specification does is that it allows you to, let's say, define certain rules. For example, well, these rules need to be obeyed when you write down the BNF or network service descriptor. So, yeah, for example, we could define that an interface has certain attributes, or that a virtual machine can have many interfaces, and that these interfaces must be addressed in a certain way. So this is more or less what the standard and the SOL6 does. It defines which entities exist within the NFV domain, and how these entities relate, and how we can use them to write descriptors. Well, as I was saying, not only OSM adopts this Solution 6 specification, we have also needed to augment it through young mechanism. And this augment here, which allows us to extend the solution 6 model, the young model, and allow us to include new features that are not yet present in the standard. So what this means is that we are taking the standard, we are complying with it, and at the same time we are making it richer. We are improving it and adding more features that we have already seen useful from our practical experience. So this point here is important because, as I was saying, we have already been working on this. We have experience, we have our former OSM specific models, so we can use all of this background to improve and go back to what the standard already offered. So, well, again, we augmented the solution 6 model. We ensured no functionality was lost from previous OSM versions. And, well, now these standards, well, they have already been documented and sent back to the ETSI for discussion and revision. So hopefully this feedback can be included in future releases of the standard. Okay, now benefits. Well, as you may imagine, the main benefits of this continuous improvement loop from adopting the standards are related with consistency and quality of the produced packages. These standard packages enhance design, management, well, and interoperability. And all of this results in the expansion of the OSM ecosystem. It's like Gerardo was saying before, that we can, instead of having a particular package for each beam or for each vendor or whatever, we have a standard and something that allows us to specify in a consistent way the same attributes for all of them. Well, so by adopting the ETSI NFV standards, OSM boosts its ecosystem growth and ensures an standard-based development and maintenance of the packages. And well, as we have already mentioned, this process allows us to provide valuable feedback in return to the standards. This is not something new, actually. The OSM is part of it's a project of the ETSI group, and this picture here shows some of the alignment of standards that have already happened or are currently ongoing. For example, the SOL2 and SOL5 standards are available since, I think, release 7. And while it's ongoing, the SOL4 standard is targeted for release 10. Well, the SOL6 standard is the one we are talking about. So you see this process is continuous, and again, we hope this helps to improve the standards and with our experience as a community. So, what are the takeaways from this alignment process? Again, well, standards alignment is at the heart of the OSM project. It is important for us to continually get aligned with the standards because, and this is the main reason, this relationship between OSM and the ETSI NFV, the ISGs, the industry specification group, which is the people that, the committee that write these standards. This relationship ensures both the standard and our software are growing into a maturity path. So this is why this loop process of continuous improvement is desired. Well, and finally, the packages and tools we are developing are continuously getting validated. For example, we held the plug test event last month, and today we have the Hackfest and all this week. So again, all of this contributes with this practical experience we get and which we can use to improve the standards and keep working into a better, more consistent and with more quality way of expressing virtualized network functions. So what else? Well, we have been talking about this process and mainly the purposes why we were aligning with the Solution 6 standard. Now I want to show you a little of these Solution 6 descriptors. The idea here is not to go really into depth of every capability you can add on a descriptor. For that, well, for the most important ones, you have this Hackfest and the sessions. So you will be seeing most of them this week. And for the other ones, well, Gerardo already mentioned the GitLab pages and the descriptor trees, so you can check there into more detail which things can be expressed and which things cannot be expressed, or how things are getting expressed with this standard. But well, I only wanted to show you, I think there are 6 or 7 pictures for both BNF and NS descriptors. But again, the idea is so you can have a little more grasp and understand, because we were talking that this is YAML, this is a YAML file, this is a descriptor, but well, the idea is to show you one. So let's look first how is a simple BNFD descriptor. So we are specifying here the virtual network function. This image here has here on the left a part of the YAML, and this one here on the right is an image extracted from the OSM UI. The OSM UI has a composer which allows you to graphically review who is the BNF or the NS. So what I'm doing here is just taking this screenshot and marking some of the things that I can see relevant. So again, this is a regular YAML file. These fields are specified by the SOL006 standard. So when I say here BNFD, as a field. This is because the SOL006 standard has already specified that a BNFD container exists within this YAML, and this BNFD can have all of these attributes. So you see here there are some basic attributes like an ID, a name, a description, a version. So I'm not going into much more detail into them. There's a management connection point, which for us it serves as let's say the interface against which we are going to run all of these configurations, operations, which Gerardo talked about. And I think this is the next or the other next session. So you will be looking into, again, into this with more detail. And here in blue, what you see is that we have a block of, this means the external connection point descriptors. So these are the, let's say, the interfaces that get exposed from our BNF to the outside world. If you come from previous Hackfest, on our previous model, OSM-8, we used to have only one type, let's say, field or list of connection points, and there we specify if they were exposed to the outer world or not. So if they were external or internal. In SOL006, all connection points have to be internal, and then you can add these ones as external. So these are the ones that are actually getting exposed. And well, as you can see here, they are pointing to the internal connection points. So this blue block here on the left matches with the two external connection points marked on blue on the right. So this management and these data external connection points are the ones enclosed there. If we go a little down, you can see here that an internal, let's say, network exists. This int virtual link, again, if you come from previous Hackfest, it's an internal virtual link, which means it's a way of connecting two of these connection points, but in an internal fashion. So this is to say that this virtual machine and this virtual machine here are internally connected through this internal virtual link. Well, again, if you come from previous Hackfest, we used to here list which connection points this link was joining, but well, linking. But on SOL006, this is specified on the internal connection point descriptors. So it's actually here a little below. Well, as you may have seen on the previous session, the main part of these BNFD descriptors are the either the BDUs or PDUs or KDUs, but basically these BDU structures specifies virtual machines. So each element in this BDU list is an instance of a virtual machine, which can have these connection points, which again can be internal or external. So here, if you see, there's this management virtual machine, which is the one that is signaled here. And this management virtual machine has a list of connection points that, again, this is a way of saying like interfaces. So this virtual machine has 2 connection points. If you remember, this connection point was the one that was exposed externally. So this is the management here. And this other one here is the internal connection point, which is used for communicating with this other virtual machine through this virtual link. So this second interface, let's say, has virtual network interface requirement and has a internal virtual link descriptor that makes it point to this internal BLD. And in a similar way, we have this other data VM, which again, it's basically a mirror of the other one. It has this other internal CPD, which points to this other internal link descriptor. And of course, it also has another internal CPD, which is the one that was exposed before. So this more or less summarizes or overviews a little of how our BNF being described by SOL6. Of course, there are a lot more other fields and complex things. You will be seeing some of them this week. Now, again, for the network service descriptor, again, this NSD field here is specified by the Solution 6 standard, and each of these fields here are also specified on the standard. For a network service descriptor, again, we see there are some general fields like an ID, a description, a name, and a version. And since the network service imports, let's say imports the BNFD packages, what we are doing here is we have a list of BNFDs which we are using. So we are saying here that this NSD is going to be using this other BNF. Okay, so if you see on the picture from the composer on the right, we can see that on the upper half we have a BNF with two externally exposed connection points, and on the lower half we have the same extractor replicated. If you notice here, what we are doing is we are importing only one BNF descriptor, but we are instantiating it twice. So that's why these two have the same names and they look exactly the same. And again, since network service descriptors are written by the operator, so they are written by the people who are importing, using, and connecting the BNFs, it is natural that they can again make some connections and specify these links between BNFs. So what we are doing here is defining again two virtual links for these two BNFs. So we are connecting the two data external points of this BNF to this datanet link, and we are connecting this to management connection points with this management virtual link. Again, there's no need to look into a lot of detail of that here. Then just making an overview of some of the common things that we do on these descriptors. So as I said, we are instantiating two BNFs. they are listed here. If you can see, there's a BNF with ID 1 and another BNF here below with ID 2. And this BNF with ID 1, since we suppose this BNF was exposing these two connection points externally, we're also calling them and declaring them and making them point to our virtual link descriptors that are here. So this block specifies one of the two BNFs. If we go to the second BNF, you will see it's actually the same. So actually we are guessing here that this block is specifying the BNF of the bottom because the two BNFs are the same. But well, basically that's the thing. On the network service descriptor, we are importing these BNF descriptors, and we can arrange them or connect them with these links using, of course, only the connection points that are exposed externally. Now, after having shown you a little of how this solution 6 descriptor look, I wanted to talk about the portability from release 8, because as we have already mentioned, this solution 6 alignment started and is brand new here from release 9. And what we have decided is that we will only support solution 6 as the model for our BNF descriptors and our network service descriptors, which means that release 8 descriptors, so the previous, the ones that you were using, for example, in the last Hackfest, cannot be onboarded into OSM release 9. So, well, what we did to preserve the old descriptors from release 8 backwards was to provide a CLI translator tool. So this CLI is already available as part of the OSM client. So it's already on your environment to use. I'm going to give you a quick demo. It won't be, let's say, step by step with you at the same time, but I'm listing there the step because it's actually pretty easy. And well, this translator, what allowed us to do was to take all the previously available descriptors, so all the descriptors we have and that we use, for example, for latest Hackfest, and convert them to SOL6 format. So all these SOL6 descriptors are already available on the GitLab BNF onboarding repository. Here is where we list all the packages and examples that we use for Hackfest and for testings. So you will see there that currently on the master branch, all files are already in SOL6 format. And they were all converted with this translator. So how does this translation process work? Basically, there are only two commands on the client. One is the package validate, which, as you can see here in the description, what it does is validate the descriptors of a certain path or folder. So if you have one descriptor and you don't know if OSM will be able to, let's say if you will be able to onboard it to OSM, you can just run the OSM client and it will tell you if it is valid or it's not. And what it provides, it's an old flag, which will allow it to tell you if packages are in the previous release 8 format or not. So you can easily use this command to quickly note if your YAMLs are already compliant with SOL6 or not, or if they are compliant with the previous OSM version. And of course, there is a package translate command, which will do this translation. So you will pass it a directory or path, so a folder path as an option, and it will read the descriptor on that file and convert it to solution 6. Again, it has some options, but basically that's the procedure. So I'm going to do a quick demo of these two commands. It's nothing for you to follow my steps at the same time, but it's really simple and fast. So, but well, again, the steps are actually there on the slides if you want. So, in order to translate an old descriptor to the new SOL6 format, of course, you need first an older descriptor and an old OSM V8 valid descriptor, because we are converting from that to release 9. So, for example, you can use any of the ones of the BNF onboarding repos. So this OSM packages repository, and there is a V8 branch. So you can take any of the files of the branch and use them. For example, you can, well, here we are doing it with curl, but you can open it on the browser and just copy and paste it. But you can take this one, and as you can see, it has an older format. If you come from previous Hackfest, you will notice it is the format that you remember. But if you don't worry. Notice here that there's this BNFD catalog key, which SOL6 wasn't like that. It was just BNFD. And also notice there's a name or a short name, which SOL6 wasn't like that. It was like a product name, I think. So this is an old descriptor. Okay. Now, if you run the package validate command with the client, you will see this error telling you that it's not in SOL6 format. Okay. And again, if you run it with the -- old option, this validation will indeed say it is okay, but because it will be using it and it will be validating it against the older information model. So that's what we want. We want to verify that this package is on the older version and not in SOL6. Once we know that, we can just run the package translate command, and you will see the package will be translated. And if you validate it again, now it will say, hey, it's okay, even without the -- old option, because it is now in SOL6. So, any questions? I'm going to show this on the terminal. Check if there's questions. Okay. So it seems good here. Okay. Can you see my terminal here? Okay.
Everything looks fine, Alejandro.
Okay. For the example here, I have two descriptors instead of one. So if we open this, I have a BNFD and an NSD descriptor. So if we open one of these, here you can check that it says, hey, it's NSD catalog, and this is really the old OSM-MR format. Again, also with the BNF descriptor, which is hey BNFD catalog, and it has all these. I mean, it's a different structure. It's a different information model, so we will need to run and follow the steps on the guide. Again, the first command was the package validate. If we run it with the help flag, we can see that there's a recursive option and a null option here. Let's do it recursive so I can use the directory where I'm standing and validate the two packages at the same time. So of course, the two packages are not in SOL6 format, and if I use the old option, you will see that now they are valid. What does this mean? If they are not in SOL6 format, but with the old option they are valid, then these packages are in OSM-MR format, which is what we already knew. But, okay, so we are now in the conditions of translating them. So instead of running package validate, we can run OSM Package Translate. So here we have the options. We can perform a dry run if we don't want to do the translation. This could be useful, for example, if we first want to detect which packages will be translated, which ones won't. But since we know that we only have these two descriptors and we know they're already on V8, let's do this for real. So I'm going to run the package translate with the recursive option on the path where we are. So you can see here that it detected the two descriptors, one of type NSD and the other one of type BNFD. It detected they were valid, and now they have been translated. So if we now open one of the descriptors, and voila, we can see it's on the SOL6 format, which had this, for example, this external connection point descriptor key or the deployment flavor or whatever. Just by reading the first line, it's not BNFD catalog, it's BNFD. You can quickly note it has been translated. So if this has been translated, it means we can validate it again. Recursive dot. Oh, sorry. Hit enter. Validate. So now note that I didn't use the old option. So these packages were compared against the SOL6 information model. So what the client is doing as here is saying, hey, these two YAMLs are compliant with the SOL6 models. Actually, you can see that here, instead of saying they are NSD or BNFD, it's also saying that they are Hcnv, so they are solution 6 compliant. So, well, as promised, it took only like 2 minutes. So now this was everything. So again, thank you guys.